Hi guys and welcome. Today we'll be talking about differential equations, growth and decay. More specifically growth and decay. Now separable differential equations. If dy over dx equals fy times g of x, then if I divide both sides by f of y and times both sides by d of x, what we can do is we can do the integral of both sides and to be able to get work backwards to the equation we want. The equation in the beginning that wasn't our differential equation but was actually our function. Okay, let me move that integral sign over a little bit. There we go. Now it looks pretty. Okay, now the law of exponential change. Now you can actually explain how this equation is arrived to by using this formula and doing this separable differential equations. So if you do the separable differential equations on this, you should be able to get it down to this formula, which is the exponential rule. Now k is the growth constant if k is greater than 0, or it's the decay constant if k is less than 0. Okay, and something important to understand too is that at y sub 0, basically y becomes y sub 0 when t equals 0. Okay. All right, let me move that over a little bit. There we go. Radioactive decay is defined as y equals y sub 0 times e to the negative k times t. And half-life, if you do some work on here and you set this y equal to 1/2 y sub 0, you can actually work this down to find that half-life is always going to be the natural log of 2 divided by k. And you are going to have to remember the rule. Hold on, I just wrote it down. The rule that when you do the natural log of 1 over a, that is also equal to the negative of the natural log of a. Okay, because if you remember when you're doing fractions with logs, the actual answer, you can actually do the negative of the log because this is technically the natural log of a to the negative 1. Okay, so technically that's how that works out, and then you can bring the negative 1 in front and voila, you actually have it. Okay, now continuous compounded interest is if you're continuously compounding your interest, and as you can see it is also an exponential growth type of problem, and we're going to re-represent that as capital A to the t, or a is a function of t, a times e to the rt, and r is definitely going to be your rate. And hold on one second, let me put the 0 in there, and that's going to be a sub 0. So that's going to be the initial amount. I like to tell this that the total amount is equal to the principal times e to the rate times time, especially for exponential growth and decay. Okay? Okay, so if we were actually to do some separable differential equations, just to give you an idea of what's going on, what we would do is we would actually work with something that looks a little like this. Okay? What we could do is we could actually go 1 over y squared, or actually just bring this to be y to the negative second dy equals x squared dx, and then I could do the integral of both sides. Now, it's not the nicest integral sign in the world, but it actually just does work just as well. Okay, and so what's happening is you're doing the integral of both sides, you're doing anti-differentiation, and you're going to get negative y to the negative 1 equals x to the third divided by 3 plus c. Now normally you couldn't find c and you would be just going, well, I just have a c at the end. But you know what y equals when x equals. Okay, now we have y and x, so we might as well plug them in. So this becomes negative 1 equals 1/3 plus c. So now I can actually find c, and c is going to be negative 4/3. Okay, now I can plug that back in to here. So I'm going to go back in. So this is negative y to the negative 1 equals x to the third divided by 3 plus, no, in this case it's going to be minus 4/3. Okay, so we have this all set up. Now we can combine the top over there, and I will get y to the negative 1. I'm going to divide both sides by the negative, so this is going to turn into 4 minus x to the third put that in parentheses. And since they're both have the same common denominator, I can subtract them. Now, since this is the reciprocal, if I just go ahead and make that a positive, then I flip this side as well. So this becomes 3 divided by 4 minus x cubed. And voila! I've actually done some separable differentiation. Okay. Now, when you're working on the problems and going over the exponential changes, just take your time, pay attention to what the fact is when you work out this stuff. Just take your time. It's hugely important just to be able to slow down and to be able to work on this stuff. So, like for example, if you're depositing $8,000 in an account that pays 6.3% annual interest, how much will you have 8 years later if the interest is compounded continuously or compounded quarterly? Okay, and so you just plug in your equations, and it should be just pretty easy just to work with. Okay, well, that is it for solving separable differentiable equations. I will talk to you later. Bye.